Okay, here we go with problem 1 on the IB practice problems with sign diagrams and calculator. So here we have a diagram of the derivative. So this is the gradient function. So this function tells us the gradient or the slope of the function f. Okay, so that means any value on here for x, when I find corresponding value for y, that y value is the slope of the original function at the identical x value. Okay, so these values on here are slopes. Any y value on here, any function value, any y value on here is a slope on the original function f. So the graph, the derivative, has a local minimum at a, so this is a minimum right there, a local maximum at b, and it passes through the point 4, -2. The point 4, 3 lies on the original function. So if I put on 4 and 3 right there, that would be on the actual function f. Okay, so write down the gradient of the curve of f at point P. So this is P. The gradient right here is given by the derivative. So if I go to my derivative function, my gradient function, the y value is what the slope is going to be on the original function right here. So therefore, the gradient is equal to -2. So I could write m equals -2. Notice it says write down. So that's a hint that I don't have to do any calculations. I just need to find the information in the graph that was given to me. All right, that's it for part A. Part B, find the equation of the normal to the curve of f at point P. So at point P, I have the tangent is going to be having a slope of -2. So that would be the tangent has a slope of -2. But the normal is going to be perpendicular. So the normal is going to be like this. So the normal, it's going to have a gradient that is the opposite reciprocal. So it's going to be positive 1/2. So now I'm going to write my equation. I also have the point because this point P is on the tangent and it's on the normal, and I know point P is 4 and 3. So I'm going to do my y equals mx plus b. I know that m is equal to 1/2, and my point is going to be 4, 3. So I have 3 is equal to 1/2, x is 4, plus b. Oops, pardon me. Simplify that. 3 is equal to 1/2 of 4 is 2, plus b minus 2 from both sides. 3 minus 2 is 1. So my normal equation is y is equal to 1/2 x plus 1. That is the equation of the normal. All right, now determine the concavity of the graph of f between 4 and 5, so in here, and justify your answer. All right, so what we need to do to figure out the concavity, I need to take the derivative of this function here. So I'm going to go ahead and write myself a sign diagram. So for the given derivative that I have up here for f prime of x, I'm going to go ahead and write my sign diagram. So I have some x-intercepts. I have one at 6. And I have one close to -1, not quite, so maybe -0.8. And then I have positive function values. And then I have lots of negative function values and positive function values. So there is my sign diagram for the first derivative. The second derivative, I'm going to make that one. To make the derivative of this, the second derivative is the derivative of the first derivative, so I need to take the derivative of this one. My x-intercepts are going to be the maximum and minimums from this graph. So I have like 1.5. Did they tell me where point A is? Point A? No, it doesn't. Okay, so point A looks like it's at like 1.5. So 1.5 is where I have a minimum, and at 6, I have a maximum. So right here and right here, that's what I put on here. And then I have to worry about the slope. The slope on here is what goes on here. So to the left of 1.5, I have a negative slope. Then between 1.5 and 6, I have a positive slope, and then after 6, I have a negative slope. So this is my second derivative. Okay, so first derivative, I just use the function values to do my pluses and minuses, and I use the actual x-intercepts. And then to take the derivative of that, I use the maximum and minimum to find my x-intercepts. And I use the slope of this, graph to do my pluses and minuses. Okay, so now, since this is the second derivative, this tells me about concavity. So I have concave down, concave up, and concave down. So where is the interval 4 and 5? That's going to be right in here. So it's going to be concave up. Concave up. So and my justification is showing my second derivative of my first derivative. Sorry, showing the second derivative of the function is my justification. Okay, so that was problem 1.